Hello everyone, welcome to Programming Knowledge. In this lecture, I am going to start MQTT message format. Before starting message format, it is important to note that MQTT uses command and command acknowledgement format. That means each command has an associated acknowledgement. Like as shown in the figure, connect command has connect acknowledgement, subscribe command has subscribe acknowledgement, publish command has publish acknowledgement. It is similar to handshaking mechanism. Now, let's see MQTT packet structure, or in general term, MQTT message format. The MQTT packet or message format consists of a 2-byte fixed header which is always present in a message, and variable header which is not always present, and payload which is also not always present in the message. Payload contains the data being sent. So you are all thinking that payload section is compulsory, but we will see in the later slide that many command in MQTT does not require payload, or in other words does not contains the message data to be sent. Example like disconnect message. This is a fixed header format. As you can see, there are 2 bytes. The first byte contained the MQTT control packet type and flag specific to each MQTT packet type, and the second byte have the remaining length. MQTT control packet type occupies 4 bit, that is 7 to 4 bit position. This 4 bit is an unsigned value, and each value represent one MQTT control packet type, and the remaining bits, that is 3 to 0 or byte 1 in the fixed header, contains flag specific to each MQTT control packet type. The remaining length is a variable byte integer that represents the number of bytes remaining within the current control packet, including data in the variable header and the payload. In the more informal way, remaining length is nothing but the length of variable header plus length of payload. We will see remaining length in detail in the later part of the course. Now, these are all the MQTT control packet type with 4 bit unsigned value and its direction of flow. As you can see here, every command is followed by the acknowledgement command, like connect have acknowledgement connect, publish has pubback, pubrec, pubdel and pubcomp, subscribe have subpack, and unsubscribe have unsubpack. Now, these are all the flag value associated with the command. Here, the reserved refer to the future use. That means it is not being used right now. As we are seeing in the publish command, the flag bit are further subdivided into DUP, which stands for duplicate delivery of publish packet, QoS, which stand for publish quality of service, and retain, which stand for retained message flag. The important point to note here is that if there is an invalid flag are received, then it is a malformed packet. Let's look some important point about the remaining length in the fixed header. The remaining length is a variable byte integer that represents the number of bytes remaining within the current control packet, including data in the variable header and the payload. In the simple term, remaining length is the length of the variable header plus length of the payload. That is, for example, if the variable header length is 10, and the length of payload is 20, then the remaining length should be 30. Right. So remaining length can be used up to 4 byte. Remaining length start from the second byte and it is used up to 4 byte. It uses 7 bit for the length and the MSB bit is used as a continuation of flag. If the continuation flag is 1, it represent next byte is also a part of the remaining length. If the continuation bit is 0, it represent byte is the that byte is the last one of the remaining length. Now let's see some important point about the variable header. Some types of MQTT control packet contains a variable header component. It resides between the fixed header and the payload, as we have seen earlier. The content of the variable header varies depending on the packet type. The packet and identifier of the variable header is common in several packet types. The variable header component of many of the MQTT control packet type include 2-byte integer, that is packet identifier field. The packet identifier field of variable header is common in several packet types. The following packet contains a packet identifier. These are the following packet, just like publish, pavac, pubrec, pubdel, pubcom, subscribe, subback, unsubscribe, unsubback. Let's see some important point of packet identifier. A publish packet must not contain a packet identifier if its QoS value is set to 0. That is quality of service value is set to 0. So whenever I am telling about the packet identifier of publish message, then it means that its QoS is greater than 0. Each time client sends a new subscribe, unsubscribe or publish MQTT control packet, it must assign it a non-zero packet identifier that is currently unused. The important point is that is currently unused. Each time a server sends a new publish MQTT control packet, it must assign it a non-zero packet identifier that is currently unused. A pubback, pubrec, pubdel or pubcom packet, which is the acknowledgement command of the publish, must contain the same packet identifier. The important point is it contain the acknowledgement command of publish contain the same packet identifier as the publish packet that was originally sent. A subback and unsubback, which is the acknowledgement command of the subscribe and unsubscribe command respectively, must contain the packet identifier that was used in the corresponding subscribe and unsubscribe packet respectively. The packet identifier becomes available for reuse after the sender has processed the corresponding acknowledgement packet. Just like if the QoS is 1, then the publish have acknowledgement pubback. So if it process the pubback, then that packet identifier is again reusable. Now let's see some important point about the payload. Some MQTT control packet contains a payload as a final part of the packet. The payload field usually contains the data which is being sent. This is the message content. For example, for connect packet, the payload is client ID and username and password. In publish packet, payload is just a message. Now, these are all the command list which have payload field and some have not payload field. Like in connect, payload is necessary. Connect acknowledgement of connect, so there is no payload. In publish, this field is optional. Payload field is optional. This is the important point. All the acknowledgement of publish does not have the payload field. In the case of subscribe and unsubscribe, the message packet have payload field and its acknowledgement. Subpack and unsubpack also have the payload field. So that's all for the today lecture. We are going to see the details of the message format. We will you take the examples of the publish, and as well as we will also discuss the QoS, quality of service, in more details. Okay guys, thank you.